So thanks, Raghavendra. Now at this stage, we're going to proceed with the demo to actually deploy our EKS Anywhere cluster.
Yeah.
Now we do have the EKS cluster now set up in AWS. The persistent storage has been, the CSI drivers have been installed. The sock shop application has not been deployed yet. I mean, only this bare minimum setup has been done. The cluster is running, right? And now we will go ahead actually and deploy the EKS Anywhere cluster, which is on my vSphere environment. So first, let's look at the AWS console. You can see this. There's one cluster. EKS is the provider. It's running 1.23. Blah blah blah. And in my vSphere console, you can see this is a on-premises setup for vSphere. Okay, it's a governed environment, which is very typical of a enterprise with all the security access controls and all that, right? Point is that there is an empty folder here, test EKS Anywhere. Right now, there are no virtual machines inside of this folder, which represent the EKS Anywhere cluster. Now, for the audience who has been following the Saga series, you would know exactly what would happen when I create the cluster. You will have 7 virtual machines come up, 3 etcd nodes, 2 master nodes, and 2 worker nodes. Okay, so right now this is the blank slate. Let's start ahead, and the other point is basically that as a part of the Saga series, we do have the the main parent blog in which we have already described how to create the clusters, whether in a given topology like a standalone cluster or a cluster with a dedicated management cluster, right? Plus, there are blogs individually noted for how to deploy the CSI drivers for PowerStore, how to actually deploy a Metal LB load balancer, and also how to actually integrate it with EKS console. Now, what we are going to do in this particular, just to kind of ease up the effort and speed it up, I have a script created that aggregates all of these individual steps, like the cluster creation, the CSI driver deployment for PowerStore, the Metal LB, the ingress controller creation, and integrating with the EKS Anywhere, the EKS console in public cloud. Now, console integration from an AWS standpoint is not a mandatory requirement for EKS Anywhere clusters. You don't need anything, or there is no dependency on AWS cloud and your AWS account to deploy EKS Anywhere clusters. So you can independently run these Kubernetes clusters at scale and whatnot. But if you do want to actually have a consistent view, a dashboard of sorts, where you can look at your hybrid, clusters like EKS clusters and EKS Anywhere clusters in the same AWS console, then there is an additional setup required on the EKS Anywhere cluster that actually requires IAM privileges to actually register this cluster with your AWS account, right? So in this particular script, we're going to kind of take all these individual steps, and they have been aggregated into a single script as such. So I'm going to run this particular script, and we will come back. Let me first start running it.
Do we call this Umber's automation?
You can call it. It's a simple bash script, right? I mean, it's all the commands that are kind of put into a if-else statement and things like that, right? Yeah. With some of the SCD statements and all that. So it's a simple bash script. Nevertheless, we'll start. The workload cluster name that I'm going to give this cluster is C4 EKSA1. So instead of being called as, so we'll just, EKSA stands for EKS Anywhere, right? So we'll just go ahead with, and I'll just say V1. So vSphere, let's say that, right? Okay. Yeah. The management cluster name, I already have a management cluster running. I'm deploying a workload cluster here, EKSA. I need one IP address, which will be actually for the API server access. Okay. Let's just put it as 13, for example. Okay. Now, this is a private IP. This is going to give me the cluster access through kubeconfig and whatnot. This is the IP, floating IP, that will run on the API server, in the control plane. Okay. Now, I'm going to run the script. I've already, provided with some defaults so that I can easily kind of, execute routine demos. So 1.23 is the version that will be deployed on the cluster. The CSI version for PowerStore will be 2.5.0. I already have the IP address inserted here for my PowerStore array, which is 185.106. This is the global ID of the PowerStore array, and the username that will be required for the credentials for my PowerStore array, because the CSI drivers will try to contact, the PowerStore array. So the credentials here. Okay, and this is a script. You can always go to the GitHub, download this script, and customize it in case you're not using a PowerStore array. You're using the default, storage class, which is based on vSAN or VMFS. I mean, whatever it is actually, right? In terms of vVols, basically the vSphere CSI. Yeah. If you're using vSphere CSI, which is the default embedded CSI inside of EKS, you can just delete those, PowerStore array commands. But here we're trying to showcase how they'll bring forward a totality in terms of storage, the compute or the vSphere cluster for the EKS Anywhere clusters, and then the integration with our data protection. So let's go ahead. Metal LB is the equivalent of the network load balancer. So we are having a software-defined load balancer as a cloud-native load balancer deployed on the cluster itself. I'm going to input the range of IP addresses that will be used to expose the services running on Kubernetes. Okay. And now you can see that the cluster creation process has started. I'm not going to, detail it out. It's already covered in the blogs, the earlier blogs and all that. But you can say the process has started. I will pause the video and come back when the entire process of the cluster creation plus the add-on deployments is over. Right? Let's take a quick pause.
That's good.
Okay, so Raghavendra, you can see that the entire script execution is over. Okay, you can see that it started with the fact that we provided these inputs to the script, which is the create cluster with add-ons. I gave the series of inputs here. The whole process started with validating, the prerequisites with vSphere. Different kind of validations are happening so that, the cluster creation doesn't fail. And then finally, the cluster got created here. You can see the Amazon EKS Anywhere cluster got created. And then the script actually progressed to actually installing the CSI PowerStore drivers actually, right? And you can see that this process is also done to a point where we can see that, the driver installation is happening on the Kubernetes nodes of EKS Anywhere cluster, and it reports success. And then after that, the Metal LB, thing actually started here. I do see my script had one error. I think I had given a double slash here, so I'll just have to repeat this command, just to kind of deploy the storage class. That's okay. We'll come back to this. Now, let's see here. Okay. Now you can see that the Metal LB configuration has been done. The Nginx ingress controller has also been deployed as a part of the cluster creation process. And finally, the cluster has been registered in the AWS console. Okay. So there are various configurations that go in terms of, creating the EKS connector service and things like that, that will hook up my on-prem EKS Anywhere cluster to the AWS console. So let's validate if this console has been created in my AWS console. Let me refresh this. Okay, it'll take time. Let's see. While this happens, I'll just show you basically, you can see that now the folder here has 7 virtual machines created, and they are all prefixed with the EKS Anywhere cluster name that we provided as the input for the script, right? So you can see the 3 etcd nodes, the 2 worker nodes with MD0 here, and then the 2 control plane nodes here, right? So these are 7 virtual machines that actually make up the cluster. In EKS Anywhere, the etcd is a disaggregated form. It's not consolidated with the control plane nodes. We are keeping etcd outside of the cluster definition, the cluster nodes as such. So let's just verify here if it shows up. So now you can see on my AWS console, this cluster also shows up. How do we differentiate between these two? It's obvious from the console. You can see the provider, EKS, and then EKS Anywhere. And these will not have any EC2 instances. These are virtual machines running in vSphere, right? That you just saw, the 7 virtual machines. We can dig into this cluster, and we can go to the resources, and we can go to the cluster and verify the nodes you can see, I can see the 4 nodes, which are 2 master and the 2 control plane nodes. I told you etcd is disaggregated and outside of the, there's no kubelet running on the etcd, right? So I don't see those nodes, but the 4 nodes, which are the 2 control plane and the 2 worker nodes, they are seen here. You can correlate this by the name here, name convention. You can see 9F, and this is the same virtual machine here, 9F.
Yeah.
And likewise, you will see the other 4, right? And so now at this stage, our cluster is ready and I can see both clusters are ready, right? Yeah. EKS and EKS Anywhere. And they both have the CSI drivers installed for their respective storage providers. On EKS, it is EBS. On EKS Anywhere, it is PowerStore. Yeah. Okay. Now, I'll just correct and rectify. I mean, it's a script, right? I would have copied pasted some command. Let me just pause the video and correct that particular error for the storage class definition. And once corrected, I'll come back to the video, right?
All right.
So there was a minor // error, which we have rectified. Happens. So the point is that, there was a SED command that I was replacing the volume binding mode on the storage class from immediate to wait for first consumer, so that dynamic provisioning of volumes can happen. Okay, now starting with the fact that you've already seen that the cluster is defined in AWS console. I can see it here as a set of virtual machines. Now I need to access this cluster, right? So there is a short script on the admin machine that I will use to switch the kubectl context, to this particular cluster. So I will just say source EKS Anywhere, cluster ops, switch cluster. Okay. And my cluster name is C4 EKSA-V-1. Okay. So C4 EKSA-V-1. So now the kubectl context has been switched, which means all kubectl commands I will, be executing on this newly created EKS Anywhere cluster. You can see that when I say kubectl get nodes, I can see the 4 nodes. So now you can easily validate. You've seen it in vSphere. You've seen it on the AWS console. Now, because we're working with the cluster from kubectl, I can see it from here also, right? So this is the EKS Anywhere cluster. We've also deployed the CSI for PowerStore. So let's just kubectl get namespace. So you can see that the namespace here, CSI PowerStore, holds the pods for the CSI drivers. Okay. Yeah. So I'm going to say kubectl get pods -n CSI PowerStore. So you can see that PowerStore controller is running, and the node drivers are also running here. So combination of these 4 pods creates the total CSI deployment actually for PowerStore, right? Yeah. Now, clear. I can also verify the storage class, and this is what I will highlight the fact that, I had to change this. The script was a little misplaced. So you can see that the storage class has been created with a dynamic provisioning. The name of the storage class is PowerStore ext4. It is based on the driver, which is CSI PowerStore.delemc.com. And at the other end, in AWS EKS, you have seen that the storage provisioner was
AWS.
Yeah, EBS CSI, right? Now, the point to be noted is that, while we are deploying the external storage array to persist data, EKS Anywhere by default comes with, the integration with vSphere CSI. So if you want to persist your volumes on the underlying, you have a vSAN or a VMFS or whatnot, then you can use the CSI drivers from vSphere also, actually, right? So it's not a compulsory thing that you need an external storage, but PowerStore is a good, provisioner for, or a persistence layer for, I would say, highly intensive data services, actually, right? So it's a very performant, unified kind of storage platform, actually. Now,
also to that fact, Amber, right? The Dell PowerStore CSI also adds the advantages of replication, right, with a CSM module. So customers, when they want to replicate, etc., gives that benefit, right?
There are a lot of benefits actually to using, an external storage array, particularly when you have, your data services which are non-linear to the base cluster storage, right? So you can independently expand your data storage outside of what is actually within the cluster.
Yeah.
Okay, now at this point, we are ready with this. Let's see the diagram again. This cluster is set up. The CSI is deployed. This cluster on the right-hand side is set up. CSI is deployed, right? Now comes the part where we will now deploy the
application,
SockShop application on the EKS cluster.
Yeah.
Okay, so that's going to be in our next video. Come back to you in the next video.
Let's get back. Yeah.
Yeah.